This video is about Chapter 12, and in this video we'll talk about how to select a sample from a population. By the end of this video, you should be able to explain 3 important ideas about sampling. You should be able to define parameters and statistics. You should also be able to define bias and describe several kinds of bias. And finally, you should be able to describe different ways of sampling a population. Those include an SRS, stratified sample, a cluster sample, and systematic sample. And we'll talk about what each one of those are. First, here is our overview of statistics. Okay, we start off with a population, and then we draw a sample using randomization. Okay, in this chapter, we are looking about how to draw that sample. There are several ways to draw that sample and why it's important to use randomness. There are 3 important ideas about sampling. First, sampling is examining a part of the whole. You draw your sample from the population, which is an idea I know we've already discussed in these videos. Okay, now, there are 2 vocabulary words you have to be aware of. First, a parameter is something used in a model to describe the population. Okay, parameters describe the population. A statistic is a summary of data found from the sample's data. Okay, so statistics describe the sample. Okay, and we will use sample statistics to estimate population parameters. Now, the way to remember that is that parameter and population both start with P, and a parameter describes the population. Statistic and sample both start with S, and the statistic comes from the sample's data. Okay, number 2, randomization makes the sample look like the population. One reason that we use randomization is to make sure, or to help us make our sample look as much like the population as possible, so that our analysis about our sample would be also true for the population. So randomization is a really, really important key in sampling methods. Okay, third, which is kind of counterintuitive. This may not make a lot of sense, but it's the size of the sample, not the size of the population, that is most important when we're doing a sample. Okay, so the size of the sample is more important than the fraction of the population that is being sampled. Okay, I think the book has a good illustration of this, talking about making soup. Okay, if you use a small spoon as opposed to a big spoon, you won't have as good of an indicator of what the soup will taste like. Okay, a bigger spoon will give you a better idea of what the soup will taste like, regardless of how big or small the pot of soup is. Okay, it's the size of the sample that is most important as we're drawing samples. Okay, next topic is about bias. Bias are sampling methods that, by their nature, tend to over or underemphasize some characteristics of the population. Okay, so bias makes it so that your sample does not look like the population. Some types of bias, and this is not, an inclusive list. Some types of bias are voluntary response bias, convenience sampling, undercoverage bias, and non-response bias. And we'll talk about these in the next few slides. The problem with bias is that your sample isn't representative of the population. It doesn't look like the population, and therefore you think you can draw conclusions about your population when you shouldn't, because your sample is different by nature than the population. So, a voluntary response bias is when you invite a large group of individuals to respond and only some of them choose to respond. Okay? For example, you'll see some questionnaires on websites, or sometimes, I guess back in the day, they used to mail out surveys and people would return those. only those who feel strongly about the topic, either positive or negative, will respond. And therefore, the sample is fundamentally different from the population. Okay? The second type of bias is a convenience sample. Convenience sampling is when you sample those who are most convenient. The easiest ones to sample tend to not be a very good sample. Okay? So for example, asking your friends a question, okay, or picking the first few that you see are usually not a really good sample. There's no randomness in that, and there could be a fundamental difference between that group and the population. Undercoverage bias. Undercoverage bias is when some portion of the population is not sampled or has a smaller representation in the sample than it has in the population. This is a really good one to know, to be aware of. Okay, so for example, back in the day, they used to do a lot of telephone surveys. They have do less of that now because of caller ID and things like that. But telephone surveys, there was a problem with undercoverage bias in that it doesn't survey people that don't have telephones. Okay, usually lower income individuals who didn't have a telephone weren't included in the surveys because they didn't have a telephone. Okay, so there was an undercoverage bias. They weren't being represented in the sample for some reason. Last is a non-response bias. Similar to a voluntary response bias, if there's a survey and a large number of people don't respond, then there may be a problem, there may be some bias because you don't know the people who didn't respond what their opinions are. And that opinion may differ substantially than the people who did respond. Okay, the last major topic in this chapter are about sampling methods. There are 4 that we'll focus on. You have to know all 4 of these pretty thoroughly. Okay? The first is a simple random sample, otherwise called an SRS. This is the simplest and most common sampling method. In this method, you will get a list of the entire population. This list is called the sampling frame. And I pulled a list of common first names here. And so that would be an example of the sampling frame. Okay, so you have a list of the entire population. And you assign them a number, 1, 2, 3, 4, all the way down to the last person. Okay, then you randomly generate however many numbers you want in your sample between 1 and n, and those people become your sample. For example, if I do rand int, a function in our calculator, 1, 20, that'll give me random digits between 1 and 20. Let's just say I got 12, and then 3, and then 19, and that will become my sample because I'm randomly generating from my population a sample. That's an SRS, it's a simple random sample, the most common sampling method. The second is a stratified sample. Okay? The population is first sliced into homogeneous groups called strata. Okay? Within each group, they're all similar in some way. Then you do a simple random sample within each stratum. Okay? This is useful when the population is already in stratified groups, male, female, or freshman, sophomore, junior, senior. They're already somehow divided in a way that they are similar to each other. Okay? So for example, if I randomly generated, 2 girls from this list, and I randomly picked, now I'm using, rand int, 1, 10, or a random table of digits, and I picked, randomly get 2 boys, that would become my sample, some from the girls and some from the boys, so that each group is fairly represented, okay, which is a very nice thing. Because if you just use randomness from an SRS, you could happen to get, more girls than boys, and that could, skew some of your results if gender would make a difference in what you are sampling. Okay, third is a cluster sample. Okay, the population is divided into heterogeneous group called clusters. Okay, where the clusters are all similar to the population. a few of the clusters are randomly selected, and everyone in that cluster is sampled. So for example, if I do rand int, and I'll pick between 1 and 5, and I happen to get the number 2, then I will sample all 4 of those individuals. Okay. Now, there's sometimes a confusion between a stratified sample and a cluster sample. In a stratified sample, they're all in homogeneous groups where they're all similar for some way. And in a cluster sample, they're in clusters where each cluster looks like the population. It's similar to the population. Okay, the fourth sampling method is a systematic sample. Okay, sometimes we don't have a list of the entire population. We don't know who they will be, but we know that they will be somehow in a line at some point, or we can line them up some way. Okay, for example, customers who come into a store, stores have no idea the exact individuals who are coming, but they could, in essence, by when they walk through the door, they can kind of number them off and generate their sample by people coming through the door. Okay, or students in line to enter a cafeteria. They're somehow lined up. You will randomly choose where in the list or where in the line you are going to start. And then you will sample every nth person after that. So for example, you randomly generate a number between 1 and 10. And you start with that person. So if I randomly generate a number between 1 and 10, and I happen to get the number 1, okay, then I will start with the first person. Whatever number I randomly generate, I start with that person and then survey every 10th person after that, or every 8th person after that. And then that goes as long as it needs to go for me to get the sample that I need. Okay, the randomness in this point, now everyone always misses this point. The randomness in this method is where you start. Okay, don't miss that key component, because every sampling method, in order to reduce bias, you have to have randomness in it, and you can't just start with the first one. You have to randomly choose where in the list you are going to start. Okay, there's a lot in this video. We talked about important ideas about sampling, that it is taken from the population. We talked about the fact that randomness makes the sample look like the population. And the last one is, it's the size of the sample that's most important. And we'll see more of that idea throughout this year. We defined parameters being about the population and statistics being about the sample. Okay. We defined bias being that it differs some way from the population, and described several kinds of bias. And we described different ways to sample a population: an SRS, a simple random sample, a stratified sample, a cluster sample, and a systematic sample. Thank you so much for watching.